CEO of Data Incubator. Previously he worked as a data scientist at Foursquare, and also as a quant on Wall Street at JP Morgan and DHL. He was also a rocket scientist at NASA at one point. Long time ago. And he completed his PhD at Princeton as a Hertz Fellow and read part 3 months at Cambridge as a Marshall Scholar. So,
well, thank you. All right, I'll help you put that away. Thank you so much for that intro. Hey everyone, come grab a seat if you're still anxious. If you're trying to decide between talks, you should definitely come to this one because the other ones are really boring from what I hear. So my name is Michael, and I want to tell you a story. It's a story about the triumph over adversity. It's a story about the equality of opportunity. But most of all, it's a story about data. And first, let me just say a few words about myself. Like many of you in the audience, I'm sure I'm a recovering academic. And through that process of rehab, I went from being a PhD at Princeton to being a quant in the wonderful world of financial services in New York, to joining a VC. I was at Princeton as a sort of data science residence when that was sort of a hot thing to do, and then eventually moved over to Foursquare, headed up monetization data science, and then so our mission at the Data Incubator is to train data scientists, and a lot of that is kind of driven by the stats you see here, right? Our employers have been telling us that it's very, very hard to find data science talent. There's obviously this huge explosion in data science in the last few years. 2.5 exabytes of data being produced a day. That probably was like last year. It's probably more now. $200 billion in spending projected by Gartner. And McKinsey is saying that there's a real shortage of data scientists. Something like 200,000 data scientists and maybe even more data analysts and managers. People who can sort of help understand this data. And as you can imagine, there's going to be a lot of people who are jumping on this bandwagon, right? And on the right, you see this list of self-ascribed data scientists. These are people who are calling themselves data scientists on LinkedIn. And there's just that huge exponential growth, right? It's the hockey stick, if you will. So our mission is to fill that talent gap. And we're doing it in kind of 2 ways. The first is actually through a fellowship program. So this is maybe how you've heard of us. It's probably what we're most known for. We are trying to attract the best talents. So we have a free fellowship program for people with PhDs and master's programs. We get over 2,000 applicants each quarter. So we run this once a quarter. And we're very selective. We pick like the top 2 to 3%. And we have a very rigorous screening process. So there's a set of challenge questions. There's an application. We review their code. We interview them. Do a lot of things. And then we work with hiring companies. At this point, something around 200. There's a few of them down at the bottom. People like New York Times or Capital One or Pfizer or LinkedIn or eBay. And they sort of hire from the program. And so it's paid for by the hiring companies. The other thing we offer is a training program. And this is sort of like an internal corporate training program where some of our partners are coming to us and saying, great, we hire 1 or 2 data scientists from you a quarter, but that's not going to move the needle for us. What we need you to do is train the 5,000 data analysts we have, the army of statisticians, all those actuaries, all those people who are doing kind of, let's call it adjacent data work, who need to learn about the new data science paradigms, all the new open source tooling that's available. They need to learn more about machine learning and apply that to their work. And that's the other half of what we're doing. So before I go on, let me say a few words about what we think of as a data scientist. So the joke, I guess, around here is that if you're in Silicon Valley, a data scientist is just a statistician who's under 30. I think there's some truth in that, obviously, but for the purposes of this talk, we'll try to be a little bit more concrete about that. So we really see data scientists as sort of being comprised of 3 main components. the first is being a data analyst. So this is someone who kind of really has that foot in the business world. They really understand what it is the business wants, what it is that they are looking for, and they understand why we're trying to solve these data problems. The second component of this is what you might call a data engineer, kind of a data savvy software developer who's able to sort of go to your database and fetch that data, who's able to build a little bit of, who's able to set up a little bit of database themselves. And I think the reason for that, the reason you want someone who has both of these skills is because if you're in a large organization, and I'm sure many of you have worked, many of us have worked in organizations like this, where these are completely separate functions, you end up having somebody on the analyst team who says, hey, we need to look at this data set. Can you go get this? And send the requisition order down to the engineering team. And they sort of say, yeah, okay, we'll get you this data, but we have these other priorities, so let's work on those for a while. You know, a few months pass, and then they give you some data, and you're like, no, that's not quite right. You have to clean the values this way. Right? There's this constant back and forth, which one, slows down your development time. By the time you actually get the data, the business no longer cares about that question. And two, you know, all the people here who've done data work, we understand that like a lot of the value of the analysis that we do comes from how we clean that data and how we join the data and all those little innumerable decisions you make in your ETL data cleaning process, which often get outsourced in the data engineering department, but which are so critical for your analysis that you have to bring that in-house. That data analyst has to be involved in that process. So when we think about a data scientist, we really think about somebody who can do both, so that you don't have to have that lag time, and you don't have that misunderstanding as you try to transfer data between two people or two groups. That's probably not enough, right? I think the third aspect of being a data scientist is really something around advanced analytics, machine learning, AI, whatever you want to call it. And this is, you know, somebody who can take all these skills and then apply neural net to that, right? And we really see a data scientist as somebody who can straddle all three of these. And of course, not everyone is sort of you can almost imagine this as some sort of spectrum. It's like a three-dimensional spectrum, right? And everyone is somewhere along the spectrum. But for us, we think the data scientist is someone who actually has to at least be competent in all three of these, even if they have specific strengths in one or the other. So I said at the beginning of my talk that I wanted to tell you a story. So let me tell you the story. And this is the story of the Juilliard blind audition study. So the story goes that in the 70s and 80s, women accounted for less than 5% of musicians in symphony orchestras, in professional symphony orchestras, right? The people at Carnegie Hall or Symphony Hall. And there was an allegation of bias. The fraction of women who were auditioning was well greater than 5%. But the judging committees, which are at that time primarily male, or the allegation was that those judging committees had a hard time seeing a woman as being capable of playing on stage. Now, the powers that be sort of looked at this and they said, okay, let's institute a new policy. And the policy is whenever we have an audition, we're going to put down a curtain between the person who's auditioning and the person who's listening, between the judge and the performer. And when they put down this curtain, the results were kind of amazing. There was a 7-fold increase in the fraction of women who passed that final audition round. And the fraction of women in professional symphony orchestras went from under 5% to over 25% in just a decade. So you might ask, how does this relate to hiring? How does this relate to data science hiring? Well, when we hire people, the first thing we look at, right? The first thing we look at is really a resume. We're handed this resume, we read it. And when we do, we make a lot of snap judgments. And those judgments might not be as pernicious as something like race or sex, but they're often things like, what university did you go to? Who was your previous employer? Or even something as silly as, are we from the same hometown? Do we root for the same sports team, right? Now, some of these things, I really want to emphasize some of these things, might be kind of proxies for your ability to get the job done, right? But we think that they're at best weak proxies, and we really wanted to do something that was more scientific. So we decided to instead base our mission system on this data-driven hiring for data scientists. We're going to issue a series of challenge questions. And the idea behind the challenge questions is that they are composed of those three components of what we think it takes to be a data scientist, right? So it's a little bit of common world business sense, common sense, sorry, in the business world, right? Like, can you sort of think about a problem in a way that's not totally theoretical or abstract? Can you be practical? It's a little bit of advanced math and statistics, so we want to make sure you have that foundation there. And of course, it's a little bit of software engineering. We want to make sure you can actually write some code, because in the end, you're not doing big data, by hand on a chalkboard or something, right? You're going to write software to do this. So let me give you a sense of what some of these questions are like, and sort of how people fared on them. So one question you might want to ask is, roughly speaking, like, can you program? So here are the results. About half the people, when you sort of just ask them kind of, like if you just look at the resume, about half the people will list, oh yeah, I know Python. And this is just as an example of a language, right? So half the people will actually say, hey, I know how to program in Python. Then when you ask them to sort of solve a question, only about a third of them actually choose to use Python to solve it. Okay, so now we're moving down a little bit. You can get a sense of like, okay, what language are they really actually comfortable in or most comfortable in? Then about a quarter of people actually get the answer correct. Okay, so now we're getting smaller. And then of that quarter, only half of them, right, an eighth of the total population, actually gets it correct and in a way that's indicative of good coding style. And I think in this specific problem, the question required a certain amount of recursion. And it turns out, and I learned this by reading the answers to this, you can actually fake recursion. If you don't know how to do recursion, what you say is function 1 calls function 2, function 2 calls function 3, function 3 calls function 4, keep on going. And you just make sure that all these functions are exactly the same thing, right? And it works, right? And I think in this case, if you sort of looked at the problem, it was clear that the recursion would be bounded. Like you only had to go down 20 steps. So all you have to do is copy and paste this function 20 times, make sure you get the indices right as you go down. But it will work and it will produce the right answer. If I ever committed that code at Foursquare, people would yell at me, right? Very nasty words would be said to me. So we clearly want people who have a higher degree of software engineering proficiency than sort of copying and pasting code over and over again. And so that's kind of the population we're really looking for. Let me give you an example of another question we ask. So this is roughly speaking, do you know linear regression? Or do you know about regression analysis in general? So if you just look at resumes, 3/4 of people will say, yeah, I know about linear regression. Check that box, fill that in on a resume. About half of all people, so now I'm going to ask you a question that's kind of a predictive analytics question, right? I'm going to ask you to predict something. Only about half of all people sort of stumbled upon mentioned any notion of using regression analysis, right? Something where I'm like, well, I should really base this number on the data I've seen in a way that kind of involves training, maybe some cross-validation, something like that, right? Okay, that's good. We're getting there. And actually, only about a quarter of people proposed something that was really workable. And I think this is just like how we teach linear regression, right? We teach people linear regression by saying like, here's a bunch of points. They're almost always kind of in a straight line, and we're just going to take a ruler, we're going to line it up, and draw that straight line, and extrapolate, do all sorts of horrible things like that. So in particular, this problem was ice cream consumption. So let's pretend we had ice cream consumption every day for the last 10 years, whatever. Predict how much ice cream is going to be consumed tomorrow, and how much ice cream will be consumed several months from now. What would you do? And it turns out people basically said, well, I can plot this, right? I have ice cream consumption every day, so I just kind of plot this, this number against time, and then I can sort of do the thing where I see a trend, and I'm just going to draw a line. Now, of course, if you've ever done like any sort of predictive analytics, you'll realize this is probably a very, very bad idea, right? In particular, people will often say like, well, we really want to use recent data because that's probably more relevant. So we're going to, only use the last 5 days of data. So if in the last 5 days we happen to have seen a downward sloping trend, we expect that trend to continue. I don't know why. Similarly, the other way around, right? If we saw an upward sloping trend, we expect it to continue on forever and ever. Just keeps on going. So of course the problem really is that's not how you're supposed to really kind of do these time search problems, right? You're really supposed to sort of think about, okay, well this is ice cream consumption, so I'm guessing people are going to consume more of it in the summer than in the winter, reasonable guess. I mean, this is a thought experiment, right? So maybe what you do is you construct factors, which are like what month of the year is this, and then use those as factors in a regression, or maybe you would use a sinusoidal curve to represent that. I don't actually remember if this was sort of hourly or daily, but if it was hourly, you might imagine, well, this is like ice cream consumption in a city. People are probably not consuming it at 3 a.m., but they're more likely to consume it at 3 p.m., so the time of day probably matters, right? You build factors like that, and then you can run a linear regression or the neural net or whatever you want over that, but the point is you gotta construct some features here. You don't just sort of take the raw data and draw a line. But people really like to just take some raw data and draw a line approach. And so that's what the 22% represents, people who actually kind of understood how to construct these features. So now I want to sort of show a little bit of, so this is kind of some specific questions, and there are other questions like this. And I wanted to show some results that are sort of more aggregate results. So in the end, most people do get resumes, and the question is sort of like, what went well? Here are things that you might want to look at, maybe not, that would suggest better or worse candidates. So of the population that we got, that we get to apply, the vast majority, something like 95%, are going to use one of 3 languages, Python, R, and MATLAB. And if you look at what language they choose to solve their problem in, this is their performance relative to the average applicant. So I wish labels were larger, but that dotted line down the middle is basically the average applicant. And so you're either going to do better or worse, better to the right, worse to the left. And so you'll see that Python does better than R, which does better than the average, which does better than MATLAB. I should remember I can't pronounce the British T, so I have to just say better. And I think this is somewhat indicative of a pretty general trend that we see. A lot of the questions that we like to ask are of the form, we're not going to give you a clean CSV, right? This is going to be a little bit messy. This is going to be a little bit dirty, and you're going to have to be able to clean that data. And I think this is like, for those of us who do data science as a living, you know that that's like 90% of the work. We don't talk about it. We all just talk about like SVMs and random forests or whatever. But that's not actually what we spend very much of our time doing. We spend most of our time cleaning data and looking at it and sort of joining data and dealing with the fact that the marketing department won't give us data, right? That's what we do. And then like and so most of it really is kind of down to software engineering, and it comes down to like, you want a language that has a very large set of libraries that are backed by a huge developer community. And of these 3 languages, right, like kind of Python takes the cake there. It has all these languages, so all these libraries, sorry, for like, I have some obscure XML format that I need to parse. Well, there's a library for that, and it'll parse it for me and give it back to me in a nice way that will allow me to construct a pandas data frame easily, right? And that's what's kind of really powerful about Python in a way that I think makes it at least a little stronger for data science, at least a lot of the kind of grunge work in data science. Another thing you want to ask is, well, let's look at what universities people went to. Is that indicative of a good, is that indicative of a good performance? And if you actually look very carefully, right, so we split the population up into people who went to top 20 schools and people who don't. It turns out the people who went to top 20 schools did about 5% better than the average population, and people who didn't did about 5% worse. It's actually not a terribly indicative signal. And I think it's an interesting thing, because I think a lot of us kind of look at, oh, what school did you go to as a major proxy for quality? And maybe that evidence isn't, the evidence sort of suggests that, well, there's something there maybe, but it's not great. And then finally, I wanted to break this up and do it by degree. I hope you can see it. The font's a little small. But we have now, this is sort of people's measures from best to worse, or I should say probably best to less than best. And if you look at that, you sort of see the usual suspects, right? When we think about who makes a good data scientist, we're talking about people like mathematicians, physicists, computer scientists, statisticians. Those are the things that we think about when we think about data science, and they show up at the top of this graph. That's great. But then we also see things that you wouldn't expect, right? Environmental engineering, earth science, economics. And those are like near the top. And they're not disciplines we usually think about when we think about data science. And I think this is kind of one of those things where popular perceptions of different disciplines hasn't caught up with the reality of those disciplines. So my PhD was in applied math, but it was like financial math, so I was very close to the economists. And one thing you will see is that economics as a field is actually becoming increasingly quantitative. It's actually very quantitative these days, at least at the PhD level. And so you actually have people who are basically doing data analysis for the 5 years of their PhD, but here in the labor market, we don't really recognize that. We don't really think of them as being really strong sort of programmers. And while it is the case that many aren't, there's still a lot that are. And I think it's good to sort of use this kind of analysis to try to tease out who are the really, to tease out who's really actually good at this, as opposed to like, what are our popular perceptions about who's good at this? Not me, sorry, yeah? So this is what so people choose which one they want to fit into. I think I took some taxonomy from like US News and World Report or some, let's call them authoritative, maybe they're not, but some sort of authoritative breakdown of disciplines for the US. And obviously, like, especially if you are not, especially if you're outside the US, like so the taxonomies of what different disciplines are going to be different. So people sort of do their best to like, self-map into this. So I'll tell you what I think the difference is, but that may or may not be what other people think the difference is. But my sense is that computer science is much more about running software, and computer engineering is going to be closer to like the hardware level, like people who think about the BIOS and the kernel and like embedded systems and all those things that really scare me because they're like the C compiler or lower, right? And that just, I did that once and I was very scared of it. So I mean, moving data into registers. I'm like, yeah, I just want to write JavaScript and make like pretty animations, right? So, but yeah, I think that's my sense of what the difference is. That's how I would interpret the question. But you'd have to ask all the applicants why they chose self-segregated to one or the other. But it's a good question. Sorry, I think see another question. That's a great question. So the first question was, what's a typical applicant? So the typical, do you mean like what I call the typical applicant here is just the average score of the applicant?
But I think the description of it is also important to make sense of.
So what you mean is like, what is the typical profile of an applicant as opposed to the average score? Okay, yeah. So the people we ask for are basically STEM PhDs with the word STEM broadly defined. So that's why we include things like social science. Yeah. And I think roughly speaking, those degrees are let's say, 95% of applicants should comfortably fit within one of those categories. There are obviously exceptions, but, and sorry, the next question was? Oh yeah, so what does the degree represent? I believe this represents the PhD degree. I believe if you switch to undergrad, it doesn't matter much because most people typically keep the same degree in both. Like it's a very high percentage that do. So it doesn't really affect the results much. Yes?
Question and a comment. So let me go with the comment first. I agree with your relation of computer engineering and computer science. I have around a lot of people. Computer engineers typically think about the processor, the memory, and other stuff. The scientists, the computer scientists think about the software area, distributed system, and so on and so forth. The question is around how do you measure performance here? Like, was it clear again?
Oh yeah, so this is basically, so remember when I showed you those funnel graphs?
Right.
Yeah, so this is sort of questions like that, right? We're asking people these questions and then we sort of grade them.
question or
Exactly.
whatever.
Exactly.
How big is your sample size?
So the number of applicants is around 2,000
In total or for each?
for each quarter. So this was like, I mean, I'm too lazy to make these slides, so I did this for 1 quarter and then, right, like, I'm not going to make more slides. I'm not going to do this again. It's too much work.
I'm also curious, what kind of studies are included in the pure math?
So your question is what kind of people are in pure math?
Yeah, because I'm just curious because I think people doing like algebra and like geometry that are doing computation. So
People who are doing algebra and geometry are doing computation. They are or not? Sorry. They are not. Okay, yeah, I agree with that statement. No, exactly. So again, so people, when you apply, you sort of choose which category you go into, right? So it's a self-description. I mean, I think, well, I would classify myself as an applied mathematician. I think mathematicians in general would be able to agree upon a classification of each other as either pure or applied, right? And I don't think there's too much ambiguity there. So we can maybe, for the sake of argument, call it just an relatively objective. But I do agree with you that pure mathematicians, by and large, have no professional reason to do computation, but many of them choose to. I think computation and mathematics are like so closely related that they just sort of pick it up as a hobby. And for them, computation probably means like Haskell because they're like purists about things. But they actually have practice like hitting compiler and then having the compiler tell them, no, you forgot a semicolon or whatever the equivalent is in Haskell. So yeah, so I agree with you. A lot of them, you're right that a lot of them have, the field doesn't have anything to do with computation, but I think that a lot of people choose to do it because it's so closely related to math. Yeah, no, that's a good point. I should actually put in the variance graphs, the variance bars here. I'll have to do that for next time, but then that's a lot of work. But I'll do that for next time. That's a good point. So yeah, I know that so I think with this one, there's obviously going to be somewhat of a variance. So I don't think, number 1 and number 2, I don't know if like they're switched or not. But number 1 and like number 14 are definitely significant. I mean, I remember I like not plotting this out, but like generating the table. But I should have put the variance bar in. But for these guys, the bars are tight, so those two are significant. So let me just show you one more graph. And I think this is the kind of the point of all of that, was that even though, so here what we've done is we've taken math and chemistry. So math is in green and chemistry is in blue. And here's the histogram of people's scores. I'm a math purist, so I like to do scores between 0 and 1. And so you'll see that the right is higher. Scores, people on the right are higher, and there's fewer of them. And if you sort of look at this graph, right, you'll realize, yes, mathematicians by and large do better. The distribution for math is shifted right compared to the distribution for chemistry. But you still have chemists, right? There's that little bump at the bottom that's in blue, the bottom right. And you still have chemists who are doing really well, who are getting a score of like 0.8 or 0.9, and they're doing much better than 90% of their mathematician colleagues. And those are the people we want, right? Because in the end, we're much more about the individual than we are about these broad labels of who people are, or what degree they got, or what university they went to. We really care about just like how well did you do. And it's those people there, and yes, that distribution can be skewed much more towards math, but there'll still be some chemists. And those are the people that we want. And that's why we want to move towards a world of blind additions for data scientists. We are really looking for a way of trying to find talent which is independent of the kind of usual stereotypes we have of who's a good data scientist. And I think that's really important just because if you're in a company, you want to have diversity of thought. And you want to hire people with really different backgrounds. And this helps us break out of that kind of narrow groupthink by casting a wider net and sort of getting people from all these different backgrounds. Now we've sort of talked a lot about applying data science to the hiring process, and I sort of also said that we do a lot of stuff on corporate training as well. So I wanted to show you some stats we have about data science on learning data science. So this is a very meta talk. It's both data science for like hiring data scientists as well as for learning data science. And so this is still like an ongoing project because this is obviously a newer part of what we've been doing. But I just want to show you two things. So first of all, there's a bit of a backstory to this, so bear with me here. So we really think that data science is hard. And the reason it's hard is because it's an amalgamation of a whole bunch of different fields, right? You have to take a little bit of computation, a little bit of mathematics, a little bit of machine learning, and figure out how to put them together. You have to be able to put them together in ways that make sense, right? So this is going to be, when you do your linear regression, you want to make sure you engineer some features that are the right features, and you don't just sort of draw that dotted line for ice cream consumption into the future. That's totally inaccurate. And I think that that's, all those tools that are available are open source, so it's not like there's a large financial barrier. But the barrier really is, and I totally agree with the organizers of this conference, the barrier really is the kind of learning barrier and the understanding of all these different tools, all these different disciplines, and how do you put them together. So to kind of help people learn this, we've developed, I guess you call it like a series of mini projects. So these projects kind of cover a whole bunch of different typical use cases of data science and sort of, let's call it a canonical solution for that, to sort of solve each of these kind of typical problems. They span sort of this whole gamut. And the idea of the mini project is, look, you can go to class and like listen to Andrew Ng or myself or whoever sort of drone on about data science or machine learning, but it's not until you actually do it, until you commit code to source control, run it on your Hadoop cluster, and see it break, and realize that you just wasted 2 hours, waiting for your Hadoop cluster to tell you that there was some Java error, null pointer exception in like line 64. That's when you're actually learning how to do data science, and when you're actually learning how to do distributed computing. So we really think it's important for people to apply this, and it's really important for people to get a really rapid feedback. So to do this, we've built up these mini projects, and the mini projects have an automatic grading component. So people can sort of submit their answers and get something back. And what we see is that, well, if you look, so this is across the x-axis is again performance, and across the y-axis is we've binned up the number of submissions people have, and this is sort of their performance relative to the number of submissions. And so as you might, I should put the dashed line down the middle again, but as you might imagine, the more submissions you have, the better you do, typically. And I think this kind of goes to show that, if at first you don't succeed, try again. If you want to learn something, it's just really kind of a process of hitting your head against a wall often enough until you kind of figure it out. And it is really about persistence paying off. Except for one thing, which is there is some subset of people who are submitting between 10 and 20, the very lowest one, where some of those people do really well and those people don't. And I think what you see is that there are some people who just kind of get it right away, and there are probably people who kind of already done some of this stuff before, but they're able to do stuff, they're able to just sort of blow through this and go through the curriculum really quickly. And then the majority of people have to kind of then work for it and really keep on submitting and doing it over and over again until they really learn it. And that's fine, because what we're really aiming for is for people to learn something, and for some people that could be faster, and for some people that could be slower, and it doesn't really matter as long as you get there. But I think what we found is that this having automatically graded mini projects really helps people be able to put these things together and really learn the material in a way that's very helpful for their learning. The other thing we've done is we've sort of set up a communication channel so that people can, so that our students can talk to each other. And this is really this is really kind of a way for them to be able to help debug each other's code. Obviously, when you're dealing with computers, when you're dealing with like cleaning data, there's just some large number of innumerable details you just have to get right. And the best way to learn those is to sort of have a discussion with other people who are trying to solve the same problems. And what we found is that the people who socialize, the people who go on this channel and speak, we sort of divided it into two categories based on some like cutoff. I think it's like top 50% for socializing, the bottom 50%. The people who socialize more tend to do better. And it's not like terribly surprising, right? It's basically saying if you run into a problem, you should reach out to other people, and maybe they can help you solve your problem. And in many ways, this is not that different from like Stack Overflow, right? Like if you run into a problem when you're programming by yourself, you can just write a question on Stack Overflow. The downside of Stack Overflow is that it might take you days, weeks to get an answer back. And when you're trying to learn, you really want that kind of rapid iteration. And so I think what we've been able to do is just sort of speed up that iteration process, right? Instead of having to wait days or weeks, you can get back the answer in minutes or hours. And that's just really helpful in terms of your learning process. So between this and the automatic grading, I think we can sort of find a lot of interesting. You can try to put some data on what it is that helps people learn and why, and maybe have some guesses as to why that is. Sorry, question.
In your assessment, though, like how are you balancing soft and hard skills?
That's a really great question. So the question is, how are we able to balance hard and soft skills? So what we do is, there's a number of steps, right? And one of them is sort of the hard skills. Can you sort of answer the challenge questions? And then the other part of it is an interview. So we actually like interview people, and we talk to them, and we ask them to propose a project and try to describe it and talk about it. And we sort of see like, are you able to communicate clearly? Do you have a point when you communicate, or do you just kind of ramble? And we try really hard to sort of filter for those skills, because we know that that's just as important for employers as the technical skills are. Okay, cool. Any other questions? No? All right, cool. So let me just move on to the last part of this talk. So the last part is really about how to retain data scientists. So now that you've hired someone, what can you do to try to retain people? I guess this is in there because people kept on asking me this question, and I figured I might as well just have a slide or two about it. So there's a few strategies that people have, right? The first one is money, and I guess this is the preferred strategy of my former employers on Wall Street. Well, if you pay people enough money, they'll stay and work for you. And I think there's actually obviously some truth to that, right? Like financial remuneration is obviously an important part of a job, and you want to make sure people are fairly compensated. But in the end, I think the best people realize that, or the best managers realize that if somebody isn't happy working at a company, it's very expensive to try to keep them there. And the results you get may not be, if their heart isn't in it, the results you get aren't really going to be, they're going to be subpar, right? The second thing that people try to do is kind of have different ladder systems or different badges, right? So try to say like, you are now an advanced senior data scientist. You used to be just a senior data scientist. And like, I mean, I'm being a little facetious, but obviously that has some merit to it, right? You want people to understand what their career trajectories are. You want them to be able to say like, okay, I'm at this level. To get to the next level, I have to do these kind of things. And that's a useful thing because that helps them sort of focus their energies. And if you define the ladder correctly, hopefully they're focusing energies on developing skills that are things that you as an organization value. So that can be really good. And the other aspect of this is that people often have sort of two tracks, right? There's a kind of a technical individual contributor track, and then there's a management track. And the idea is you want to make sure that they have, going up pretty high at least, equal levels of pay and prestige, so that people who feel, technical people who feel like they want to be managers can move into the management track. But ones who don't, who want to sort of remain technical experts, and can still provide a lot of value to your organization, can move into the individual contributor track. They don't have to manage people if they don't want to, but then they can sort of move up and start getting really good at being software architects or being data pipeline architects, right? And kind of really do things at a higher level, develop a lot of deep expertise that they can train people on, and still be very valuable. So I think those are kind of useful aspects of those are kind of useful aspects of this whole notion of like having a hierarchy and ranks and badges. And then finally, there's this idea that, well, you can be a very dynamic and innovative organization, right? Those of us who are technical in this room are like, yes, we want to learn the latest and greatest. We want to download the bleeding edge branch from our favorite open source repo and put that into production right now. It's a brilliant idea. So, and that's great in the sense that it does help keep people, it does help get data scientists excited. But there's always a cost to that, right? Because if you're running a business, you have to balance getting things done and being innovative. And those are oftentimes at an opposition to one another, because one's about an investment and the other is about sort of collecting from the investments you've already made. So there, even something that like being innovative has implicitly a cost to it. But there's kind of one thing that I think we should all do, which has a pretty minimal cost. And I like to talk about it in terms of the metaphor of the speedometer and the steering wheel. So if you think about like what data science is, it's a view, it's like a speedometer. It's a view onto your organization that sort of tells you, well, this is how this part of it's functioning, that's how customer acquisition is working. This is the recommender engines telling us what customers like and how we sort of can segment them, right? And then the other half of it is that the speedometer actually wants to know the person at the wheel is looking down every once in a while and using that information that they're getting to make course corrections. So how do you operationalize my somewhat strained metaphor? Well, you want to make sure your data scientists are seeing the impact that they're having. So that could mean when you make an announcement saying, well, it's really, we looked at all this data and all this great analysis done by our data scientist, Sarah, and we decided to do this based on that analysis. It means taking your data scientists and making sure they have a voice with, and they're able to speak to senior management and get some recognition for their work. All right, so I guess I'm going to cheat a little and tell you and do one more thing, which is tell you another story. And this is a story about my friend Bob. So his name actually is Bob, and he works at this. Yeah, I know. I wish his name was something less generic, but it is actually Bob, and he works at a nonprofit called the Teen Crisis Line, and it's a very successful organization. They basically help teenagers who are sort of experiencing mental trauma. They're depressed. They're in a really tough spot, and it's a way for them to call someone and be able to get some counseling and advice to try to get them through a tough patch in their life. So it's a really amazing organization, does really great work, and it's really successful. And like most successful organizations, they feel a lot of growing pains. So their problem is that they don't have enough callers to man the lines as people are calling in at peak times. So the way you solve this is that you put people on hold. And so you have to play a little message that says, hey, welcome to Teen Crisis Line. We're currently busy at the moment. A specialist will be with you. Or the other proposed copy was a representative will be with you shortly. So think about it. You're a teenager. You're calling in. You're kind of really depressed. And you can hear one of these two messages, right? It's either going to say a representative will be with you shortly or a specialist will be with you shortly. So let's do a show of hands. How many people think representative is the right word? Raise your hand. Okay, a small crowd. How many people think specialist? All right, seems like the majority of people are saying specialist. Okay, so, so raise your hands if you said specialist again. Hands up. All right, well, it turns out you're in great company. And the reason is because they decided to host a conference. Or I think this is like a separate academic conference, but they went to this conference, they proposed this exact question. Should we tell people, should we say specialist or should we say representative? And they had experts in human psychology, team development, right? All the people you think would know something about this. They invited them. And these kind of gray-haired experts went up to their mountain and they debated for 2 whole days. And they came down like Moses with the tablets, right? And they said, specialist, you should go with specialist. And that's what they did. They went with specialist. And that's what they were doing for months and months on end. Now, how many people said representative? Raise your hand. All right, so there's a few of you guys. Well, you might not be in good company, but you're actually right. Because what happened is my friend Bob, he's actually a data scientist, and he works here. And he said, wait a minute, we could just test this, right? So what we do is when people call in, we flip a virtual coin, and 50% of the time we say specialist, and 50% of the time we say representative. And then we have a metric that we can actually measure, because what we're trying to do is just get people to hold out through, right? So there's a hold through rate, just number of people who hold through divided by the number of people who called in and got that message. And so when they did this, they ran the experiment for like 2 or 3 days, and they just shut it off after 2 or 3 days, because the results were kind of really clear, right? Representative was better, and the hold through rate was something like 3 times higher. And it was very quickly statistically significant because they get actually a pretty high volume of these calls. And this is like a really important result. So they literally get teenagers who are calling who are on the verge of suicide, right? And if they're not able to talk to someone, they may go and act on that impulse. So the ability to get someone to hold through and be able to sort of then deliver a person at the other end to sort of counsel them through and walk them off that ledge can literally save lives. So I think, the moral of the story really is that for many of the people in this audience, I think you're probably a boss. You probably manage data scientists. And well, I think the takeaway for you is that there's kind of 2 heroes in this story. One is the hero that I mentioned. It's Bob, my friend, the data scientist who came up with this experiment. The other is somebody I have not yet mentioned in the story, and it's Bob's boss. Because she sort of decided, well, instead of listening to the experts in the field, I'm going to try listening to this 20-something kid. He seems to know what he's doing, and make your decision. And she made the decision ultimately based on data, as opposed to sort of received wisdom. So I guess the moral of that story really is be much more like her. Don't be like that guy. And if you're looking to either hire data scientists, or if you're interested in getting some corporate training for your company or your organization, feel free to email me, or you can tweet at me, or you can tweet at the company. Although email is probably better because I don't really use Twitter very much. So anyways, any other questions? Go ahead.
Do you do any sort of business screening before you send this out?
Sorry, can you say that loudly?
Do you do any sort of business screening before you send out the assignment, or do you just send out the assignment to everyone, collect results back, and
so the question is, do we do any screening before we send out the challenge questions? And so the answer is yes, we do a little bit, and it's mostly actually based on whether or not we think it's really even, sort of like whether it looks like you're even trying on the application. So we ask people to do an application, and some people just kind of, you can literally do nothing and fill it out and just hit submit, right? I guess you put in your name and an email, and that'd be it. And we probably would not take somebody like that. On the other hand, and then we also sort of try to do a little bit of like, well, you might not want to even try this because you're like an English lit major from whatever. You're an English lit major or something. So there's a little bit of that, but by and large, we try to make this as unbiased as possible.
So in the abstract that I saw on the website, actually, you just mentioned that you have this machine learning, you have to rely on the machine learning for this robust analysis for the hiring process. Can you just mention a little bit about it?
Yeah, so I mean, I think it's a little, machine learning might be a fancy word for it, but I think it's much more, we just sort of get this data, and we have to analyze it, and we have to decide how much we weight all these different factors. But in the end, I'm not sure if machine learning is quite the right word for it.
Okay, so let's
Sorry.
ask it differently, actually. So to be able to ask that, so you have questions and you're asking these questions to the candidates. How you are scoring them?
Oh, because you just need to know what the answer is, right?
No, is it 1-0? What is the range? How many questions you are asking?
Yeah, so I mean, we ask, somewhere on the order of a dozen questions. It sort of differs every time, right? there's a scoring methodology. I probably won't say too much more about it, but besides the fact that there's a scoring methodology. Thank you. And I think basically, like, we know what the answer is, and we can ask the question, and we sort of, from the way you answer it, we can kind of infer how you tried to solve the question. And, you know, certain ways of solving the question are better than others, let's say, as you might imagine. All right. Sorry.
So I actually did a project similar to this in college, and I was just wondering, is there a way, or is there something that you guys ensure that a data scientist that is hired in a company, like you said, today, when before they're actually hired, is there a way to decide more qualitatively whether they would fit into the company? So I mean, the quantitative stuff we already talked about, but in terms not only in soft skills, but even like, especially in startups, especially in smaller companies where personality is something that is fit.
No, that's a really great question. So I think the question is basically, wow, it looks like you do a lot of stuff on the quantitative stuff to see if candidates are qualified. What do you do on the qualitative side? Things like social skills, or even like cultural fit and personality match between companies and companies and students. And I think what we've said is that basically that's not something that we're going to solve. I totally agree with you. That's a very important part of the hiring process. But what we're trying to do is just find technically qualified people so that our employers can then go through and ask the questions that only they can really answer, right? We cannot really know the personality types and the cultural fits for the hundreds of employers we work with. That's just like not a practical thing. But we can try to find people who are technically qualified, because I think the technical qualifications are quite similar across all these companies. So we try to focus on the part of the problem that's similar across our hiring partners, and then hand them a group of people and say, well, you guys can figure out the cultural fit afterwards, because only you are really qualified to do that. Does that make sense? Which doesn't mean that we don't try. Like, we know, obviously, we sort of say, like, this person says they're interested in finance. You're a finance company. Maybe you should talk to each other. But I don't think it's too much more sophisticated than that. And I think what we found is that, by and large, people, especially early on in their careers, don't know what they want. So, like, the most typical story is people come in and they're like, oh, I hate finance. I'll never work in finance. And then some hedge fund shows up and like says a few words and like, oh my God, that's the coolest thing ever, right? And it's like, I mean, finance is one of those careers that's like very polarizing. I think of all the industries that we work with, it's probably the most potentially polarizing. And I think when you see people make that 180-degree turn on an issue, on something like this, then it's a good sign that employers coming in and sort of like talking about what they do is actually really helpful for sort of just building brand awareness, or like demystifying what you're doing and making people think that you're not a monster. All right, I think I'm getting kicked off stage, which is great. But feel free to come and talk to me afterwards. I'm happy to answer any questions you may have.